In Linux and other Unix-like systems, file ownership and permissions control the level of access users and processes have to files and directories on the system. In a multi-user operating system such as Linux, controlling access to files is essential for maintaining security, privacy, and stability within the system. This video provides an overview of Linux file permissions, what level of access they provide, and how to manage them. In Linux, permissions are assigned to three distinct classes of users: owner, group, and other. Owner is the user who created or owns the file. Group are users belonging to the group that owns the file. Others are all other users on the system. There are three basic types of permissions: read, write, and execute. The behavior of each permission varies depending on whether the object is a file or a directory. Read allows users to view file contents or list directory contents. Write allows users to modify file contents or create or delete files in a directory. Execute allows a user to run a file as a program or access a directory, such as when changing directory. To view file permissions, use the ls command with the -l flag, which displays a detailed long listing of the file. The output includes various metadata about the file. In particular, the third and fourth fields in the output indicate the user and group that own the file. The first column of the ls output consists of 10 characters that indicate the file type and permissions. The first character represents the file type, commonly a dash for a regular file or a D for directory. The next 9 characters are grouped into 3 sets of 3, representing permissions for the owner, the owning group, and all other users. Each set follows the order read, write, and execute, with a dash indicating the absence of a permission. In this example, the owner has read, write, and execute permissions, the group has read and execute permissions, and all other users have only read permission. Permissions can also be represented using 3-digit octal numbers, where each digit corresponds to a specific access level. Read is equal to 4, write is equal to 2, and execute is equal to 1. These values are added together to form a single digit representing the combined permissions for each class, owner, group, and others. For example, a permission value of 7, 4 plus 2 plus 1, grants read, write, and execute access, while 5, 4 plus 1, allows only read and execute access. File permissions are modified with the chmod command. Chmod can be used in both symbolic mode and numeric mode. In symbolic mode, an expression made of 3 components is provided as the first argument. The expression consists of a who, an operator, and a set of permission types. Who are the target users, specifying which user category the change applies to. U is owner, G is group, O is others, and A stands for all. Operator is the action to perform, defining how permissions should be modified. Plus is an add permission, minus removes a permission, and equals sets exact permissions, replacing existing ones. Permissions are access types, specifying which permission types to assign. R equals read, W equals write, and X equals execute. The following command makes the myscript.sh file executable by the owning user. Permissions groups and types can also be concatenated to modify multiple permission groups or assign multiple permissions. The following command assigns read and execute permissions to the group and all other users. The minus operand strips permissions from the target. The following command removes the executable permission from all other users. A slightly more complex example, this command grants the owner read, write, and execute permissions, assigns read-only access to the group, and removes all permissions from others by omitting a specific type after the operator. As shown here, chmod accepts multiple comma-separated expressions for greater specificity. In numeric mode, an octal value is provided as the first argument to the command. The following command assigns read, write, and execute to the user, and read and execute to the group and all other users. To change the user or group ownership of a file or directory, use the chown command. To change the owning user of a file, provide the login name or user ID of the new owner followed by one or more files. This command changes the owner of example.txt to user jdo. To change both the user and group, provide a colon-separated user and group name. This changes the owner to jdo and the group to developers. To change the ownership of all files and subdirectories within the specified directory, use the -R flag. When files are initially created, they are assigned default permissions. The file creation mode mask, umask, in Unix Linux systems controls the default permissions for newly created files and directories. It works by specifying which permissions should be removed from the default permission set. You can view your current umask with the umask command. The UMask value uses octal notation, where each digit represents permissions for different user categories. The first digit is for special permission and is rarely used in UMask. The UMask value is subtracted from a base permission set to determine the final permissions. For files, the base permission set is typically 666. For directories, the base permission set is typically 777. For example, with UMask value of 022, new files will have 644 permission, and new directories 755. To set a new UMask value, run the UMask command with the new UMask value. As a final note, it is useful to understand where permissions and ownership tend to be important and intentionally defined in Linux systems. Configuration files such as etc contain system-wide settings and are generally readable but not writable by regular users. Home directories contain user-specific files, settings, and configurations and should be protected from other users while maintaining access for the owner. System binaries, bin, sbin, and user bin are executable files and need proper permissions to prevent unauthorized modification while allowing execution. Web server content are files served by web servers such as Apache. They need to be accessible by the service user, often www.data or Apache in Apache. Typically, the service user will have read and execute permissions on the website root directory and subdirectories and read access to files. For services like SSH, private key and authorized keys files require strict permissions, typically 600 or 400, to maintain security. Service-specific directories such as varlib PostgreSQL are used by system services and commonly owned by the service user. This has been a brief overview of basic Linux permissions. We covered how to read and understand permissions in both their symbolic and octal representations, how to configure user and group ownership of files, how to modify permissions of a file or directory as well as change ownership, and how to change the default mode for files and directories. Thanks for watching.